Hello and welcome to this video. In this video, I want to draw your attention to some glaring mistakes that are found in some of our course books. My name is Kagwe Munro and I'm a physics teacher, and I've been using course books for a very long time, but there are some mistakes that I have observed in some of those textbooks, and it makes teaching a little bit challenging, unnecessarily challenging. In this sense, I want to start by saying that teachers cannot afford to make mistakes because they are the reference point for their students, especially when their students do not understand that human beings can also make mistakes. Now here I'm referring to the mistakes that are found in the course book, that when teachers discover these mistakes and they tell the students that there are mistakes here, the student is in a very difficult position because he or she is left wondering between the textbook and the teacher, who is more correct. After all, this textbook is in circulation to very many students, and only one teacher comes up and says, there is a problem here, there is a mistake here. There's a problem with the publishers of this particular course book. Although some of the mistakes have been rectified in the subsequent editions, not all of them have been addressed, and there's still a lot of room for improvement. I want to start with the physics book 1, and in the topic measurement 1. And on my desktop, I have this page. It is from an earlier edition. I think it is from the 3rd edition of the KLB book, and it must be found on page 11. And here the students are being taught how to read the scale of a meter rule. But when you look at the readings which are given, they are 2 decimal places of a centimeter, a very high level of precision which can only be obtained with the vernier calipers. Although it makes sense to approximate such values, it is important to realize that the precision of a meter rule cannot be to two decimal places of a centimeter, because when you look at that 1 millimeter, it is very difficult for students to be able to approximate to 1/10 of a millimeter. So this one is an obvious error in this book. I'm not sure whether it has been corrected in the latest editions, but I'm talking about from the perspective of the fact that before a book gets published, someone must have gone through the manuscript thoroughly and corrected any mistakes which are found there. It's okay to get 1 or 2 mistakes in a textbook, but when the mistakes are numerous, then something is clearly wrong. For instance, the first one is this level of precision. It would have been enough if the reading is given to 69.9. That is okay, because in the practical session, if a student gives a measurement which is taken using a meter rule, and the student gives it to 2 decimal places of a centimeter, that value is always marked wrong because it does not reflect the precision of that measuring instrument. So I want to highlight some of the mistakes which are found in this book. I'm not saying that everything in the book is wrong. It's only certain things which are clearly there are some mistakes. They are so glaring that we cannot avoid them. So that is the first mistake. The other one is in drawing of the diagrams throughout the whole textbook and even the new textbooks. These diagrams have not been drawn, accurately or using the correct proportionality of the dimensions given. And here I have an example in book 2 where the measurements are clearly wrong. And in this book, it's on page 66. I think the same edition of the course book, page 66. Although the publishers have gone ahead and rectified this kind of error, it is important to note that not all students are using the latest edition, and these earlier editions are still out there, and the students are likely to come across them and get confused. Let's go to this page, page 66, and you'll be able to see this error. So in this page, you can see this diagram of here. I'm saying that this error has been corrected, but it's always good to point out because you don't know who is reading this textbook and at what level, and they may not be aware that the error has been corrected in the latest edition. And again, I want to emphasize here, such a mistake should not have passed through the person who was reading this manuscript. Let's look at it. You can see this distance here is given 12 centimeters, and yet it is clearly shorter than the distance above here, which is given 8 centimeters. How do you account for an error like that that is so glaring like this? It is not enough to say that provided the students answer the questions as given in the course book, they are going to get full marks. We are forgetting one thing. These students will go beyond the boundaries of this country, and if they have been exposed to erroneous concepts and they carry them these errors with them, they are likely to discredit the kind of education which they got in their mother country is likely to get discredited, and we really don't want to trod that path, because if our education system is discredited because of the mistakes which are found in the course book, then you find that not many people will have confidence in what the physics teachers are handling. And some of these mistakes, the physics teachers, some of them note them, and but they do not know what to do about that. And this is quite unfortunate. So that one is an error that shouldn't have been there. When we are still in the same textbook, book 2, there is an error when it comes to reading the zero error of micrometer screw gauge. I think it is on page 38. Yes, the process that has been given on how to determine the zero error is clearly wrong. I was confronted with this problem at one time when I was teaching this topic, and I was trying to tell them there is clearly something wrong in the way the zero error has been determined in those two diagrams, because it was clear to me that it was swapped. So I had a lot of trouble. I went to a lot of trouble trying to convince the students because of the same aspect. They would tend to ask the teacher, between the teacher and the textbook, who is more correct? And they are likely to go with what is in the textbook. So as a teacher, I'm not very comfortable teaching concepts which are clearly wrong. So what I did here, I went to the exercises which are given at the end of that chapter. So I went to this question here, question number 8, where the students are supposed to use the knowledge which they have learned on how the zero error is supposed to be determined to determine the zero error for the diagrams given there. So they did that as an assignment. So when it came to giving the answers, they followed the procedure in the book. And then I came with the teacher's guide. Apparently in the teacher's guide, they appear to have corrected that error, the error in the theory, because now they gave the answers correctly according to how I was trying to guide the students. It's only at that point that they got convinced that indeed there must have been an error. You see the kind of trouble we are putting teachers into. Our students are likely to have less confidence in what they hear from their teachers, because the course book, which has errors in them, is talking different. So this is just one of those errors out there. Maybe you are a teacher out there, and you may have been reading maybe book 1, book 2, book 3, or even book 4, and you may have seen some concepts which, according to you, you think there is a mistake there. I'd like to hear in the comments below what you have to say about that particular mistake, so that we can go ahead and correct these mistakes. And maybe you may be the publisher of this book and you're watching this video and wondering, what do we do with this? My aim of putting out this video out there is not to discredit this work that is done in this book. No, it is to draw attention to you that there is clearly an error somewhere which needs to be addressed. Because if it is not addressed and such information gets beyond our borders where we don't have control, we will have our system of education, or even the course books that we use, being discredited from the outside, and we really don't want that one to happen. The third thing that I have noticed with these course books, although the latest editions appear to be trying a bit, is with the accuracy of the diagrams, the proportionality of the diagrams. It's clear to me that something is missing. The diagrams are so plain. Take time to add some color to your diagrams. You can even take pictures. You can zoom in and take picture of a scale and use that one in the textbook. You can go outside and take pictures of common objects which students are using, or they are even using in the lab, and put them in the textbook. If maybe in one way or another you have a challenge with drawing diagrams. But I want to just aid you on what you can do when it comes to drawing diagrams using softwares which are in our computer. And this is the use of Microsoft Word to draw diagrams. Let me just show you what you can do in terms of drawing diagrams, adding color, and you're doing this. You're drawing diagrams from scratch. So let's go to Office 2010, and I'll be using Microsoft Word to show you how this is done. So you may be using maybe one of the latest versions of Office. It really does not matter. When you go to Insert tab, you will go to the group of tabs written Illustrations and click on Shapes. Just click on that downward arrow like that. You scroll all the way to the bottom where you've got New Canvas. You click on it and you can see a canvas appears here where I can be able to draw a diagram in my document. And let's say I want to draw that very simple diagram of a bar, a meter rule. That bar looks like a rectangle with a very large length compared to the width. So one of the shapes here, I'm going to use shapes which are already drawn, and one of them is this square. Okay, let me put it away so that I can start from scratch, so that you really understand what is it that I am doing. So let me just delete the diagram and start afresh. So I will go to that Insert, Shapes. I've already inserted the canvas. Now I'll click on it to reveal these standard shapes which are found here. We've got standard shapes such as rectangles, triangles, basic three-dimensional shapes such as cylinders, cubes, arrows, and so forth. So I will pick the one which looks like the diagram which I want to draw, and this is the rectangle. Click on it, come with the arrow, click in the canvas, and you can see. And once that shape is in the canvas, I just need to use these corners in order to change its shape and position. I can, maybe this one is a uniform meter rule. I need it to be thin and long instead of what I've seen teachers drawing, something like that, a meter rule. The meter rule clearly does not have that thickness. The thickness of meter rule is much, much smaller. And this is where I have trouble with the proportionality. The diagrams which are drawn in the course books, they are not proportional. And teachers tend to copy what is in the course book too. So it is important that the diagrams in the course books are drawn properly. And here I'm using a very simple example. I can format that shape just by going to format here. First of all, I can do something to the outline. I can change the outline, the weight of the line on the outline, and you can see the weight changes. Maybe I want to use 1 point for the thickness of the line. When it comes to filling in the color, I just go to fill in, click there, and you can see I have access to so many colors that I can use. Why am I bothering to do this? It is because when you look at the diagrams in our course books, they are so plain. They don't have color, and therefore they are not very appealing to the student. When you're drawing a diagram, make sure that you add some color to it, because you want to make the subject to be more appealing to the student. And over here, I'm showing you how you simply use Microsoft Word to draw this, add color, and you can play around with all these colors. They're available. You can even go to textures where you have access to more colors. Like for example, since this one is a piece of wood, I would go to a color like this, or to a color like this for hardwood, or any other color of your choice. Okay, let us choose a plain color such as this one here. That one there is orange. I can have it there. I can even decide to remove that outline by clicking here and saying no outline. And you can see now that one is different from the plain diagram that I had there. If I want to draw the pivot, I will go to the same shape and look for an existing shape such as the triangle. Click on it, come and click here, and drag it to the point where I want it to be. Probably that one is a very large triangle. I grab the corners and just move them in. It may be too wide. I want to make it a little bit thin, and I want it at a specific position there. Again, I can make the outline to be what I want. Maybe let me make the outline to be that thin. Change the color of the fill-in, maybe to something like yellow, green, blue, whatever color. All these colors are there, or even black. I don't mind. There it is. And you can see now the contrast is quite different, and the students are likely to pay more attention because there is a color difference instead of using those diagrams which are so plain. Let's go to arrows. I want to show maybe the weight of an object here, and you can see the moment I hover my cursor here, it shows me the center of the rule. That's where I will click because I want to put an arrow showing the weight of the meter rule. Something like that. Play around with it. I can make it very, very distinct to have very sharp edges. I can change how thick that arrow is. You can see just by going to shape outline, click on that arrow and then come to the weight of the line. And you can see the moment I hover my cursor there, I have various thicknesses of the arrow which I want. Click on that one, for example. You can even be able to change the shape of this arrow head. How? When you're still on the shape outline, click on the arrow and you'll see arrows here. And once you navigate to the left like that, you'll see more arrows. When you click on it, you will be prompted to say probably how do you want the beginning of your arrow to look like, or the end. What type do you want? Do you want this plain type, or do you want this steel arrow? Click on it and you can see it has changed. How about the size of the end arrow? Do you want that small, or do you want to make it a little bit bigger? See, so many things you can be able to do with Microsoft Word. If you're having a challenge with how to use Microsoft Word to draw diagrams, I have a video up there that I've really taken time to to show you how you can even edit a diagram which exists in your course book. You can remove the labeling, put in your own labels, add in more information. In this video, I'm showing you how to draw a diagram clearly from scratch. And you can see it is so easy. It's not difficult. For example, I've just said you want to make various aspects of your diagram to have different colors. For instance, let me change this from black to some other color because I've already used a black. Maybe I want to use red, for instance, or even blue, something like that. And then I want to show the distance from the pivot all the way to the line of action of the force. Because there's so much you can be able to learn here, and they can even improve the way you draw diagrams. For instance, I was looking at a recent textbook where you find that the students are being told that this one is a circle, and we can clearly see that it is oval. It is not a circle. How can you use Microsoft Word to draw a diagram which is very proportional? Just go to View and go to the group of tabs written Show, and then click on the grid lines. Click on that and you have a good grid that can help you to draw a perfect circle. Let's see what you do. While you're still in the canvas, and you can see the grid line now helps us to even make this diagram very proportional. While you're still there, go to Insert, and on the group of shapes, try to see whether there is a circle. And indeed there is. There is this one here. It is written oval. But when you click and put it here, it turns out to be a perfect circle. Now, what does a perfect circle have? First of all, I want the corners to start from a specific point, maybe somewhere there. I want this other to go to a specific point. So I'm going to change this shape so that it looks a certain way, in the sense that if I can see that this is the center of my diameter, this represents the diameter, how many squares do I have from the diameter all the way to the circumference? I have 1, 2, 3, 4 and a half. How about the other side? I have 1, 2, 3, 4 and a half. And I can see that it is proportional as far as this diameter is concerned. I will expect the same on this other side. 1, 2, 3, 4 and a half. And that one is a perfect circle. Is a perfect circle. What we have are diagrams which are drawn like this, and somebody is telling the students that that one is a circle. It's not a perfect circle. So you can see the kind of problems it can cause to a keen student, because a keen student is likely to get more confused. So my challenge to teachers and the publishers out there, please try to make our diagrams as proportional as possible. Add color in order for the diagrams to be more appealing. Read through the manuscript so that you remove the various obvious mistakes so that they don't get to the student. If they get to the student, our work as teachers become very difficult, trying to convince them that there is something wrong in that course book. And if you are a teacher just watching my video out there, and you may have seen 1 or 2 mistakes in any course book, it may be a physics course book or any other subject, so long as it is talking about diagrams, please let me know so that you can see, I can guide you on how to go about drawing diagrams using Microsoft Word. Otherwise, have a nice time, and I look forward to seeing you again when I'll come up with maybe something that I've seen in a textbook. This one's just a simple review of the course books that we are using in our country, and I felt inclined to mention them out here. Bye-bye.